Hello. So we're gonna be looking at the 1991 eruption of Mount Pinatubo. It's in the Philippines. Luzon Volcanic Arc. As we can see here, that's located in a north-south line across the Luzon Strait to Taiwan. From Taiwan to Luzon. Okay. That must be in the Philippines. Here we are. Yup, okay. So it's pretty general then. I was thinking maybe of some exact location here. Okay. Interesting, because Mount Pinatubo is right here. Tubo? Pinatubo. Let's take a couple ganders at this. This erupted in 1991. Okay. So there's a volcanic arc there that this is generally part of, apparently. Okay. And it erupted in 1991. It was the second largest eruption in the 20th century. Yeah, okay. Prehistory. Oh, that might be not. It's probably not about its eruption history, although maybe. Small blast marked the beginning of a new, more violent phase of the eruption. Build up. July 16, a magnitude 7.7 earthquake struck. Let's see. Where exactly? Rizal. Struck Rizal. Over here? Ew. July 16, 1990. Comparable in size to the 1906 San Francisco earthquake. 2008 Sichuan earthquake in China. Its epicenter was in the municipality Rizal, about 100 kilometers northeast of Pinatubo. That showed it north or southeast. That shows it southeast. Let's see. There's got to be a. Let's see. Over here. So it struck over here. Okay. So we had an earthquake strike over there in 1990. And faulted northwest, southeast through 3 provinces. It also followed the Philippine fault system west as far as Baguio, which was devastated and is located about 80 kilometers northeast of Pinatubo. leading volcanologists to speculate that it might ultimately have triggered the 1991 eruption, although this is impossible to prove conclusively unless we figure out how things work, and then maybe it's just like an a result of that process unfolding, where then like things like this do become conclusive, because it does seem like it would probably be capable of being conclusive, because it's probably the case. Okay. Now, there's some relationship that's pretty critical. 2 weeks after the earthquake, local residents reported steam coming from the volcano, but scientists who visited there in response found only small rock slides rather than any pre-eruptive activity. Locals are like, there's steam. That's a concern. Geologists are like, don't worry. There's no rocks. There's only small rock slides. Not to laugh about this. March 15, 1991, a succession of earthquakes were felt by villagers on the northwestern side of the volcano. So another 8 months later, some earthquakes arrive. Further earthquakes of increasing intensity were felt over the next 2 weeks, and it became clear some kind of volcanic activity was likely. On April 2nd, it makes me think of the way the Chilean earthquake. The map. This tsunami. So we've got this time elapsed. And then just to jump ahead to where it's and a day later, just about, it's arriving over here. So it's possible that the earthquake kind of like caused movements in the liquid mantle material that is contained underneath the crust, stored in the polygonal boundaries that are contained in like the space that the currents opened there, something of that nature. And mind you, there's currents going through here for sure, so we kind of saw something going on here where it seems like a current that initially came in here, like while it was adjacent over here, caused it to move away over here in some way, and then ultimately come where the current felt enough resistance going in that it basically was bent back out. So it essentially went in and then wrapped around here and then back out this way, and then again it divides here and goes this way along this boundary, and then up here up to like this boundary, I think, up this way. And then this one continues straight though, it goes across. And just goes through here to Mount Pinatubo. So for sure that is related, and that to me, like, so here's an initial thought that I was having, is that generally because there's a current that flowed this way, it produced a channel for current to flow. So when I guess this earthquake maybe caused the generally just sitting there, not so like shook up mantle material underneath the Philippines to flow, I guess, to the like there's a boundary here and also to this boundary. So I was thinking that it was involved this way, but now it sounds like there might have been an earthquake more over here that somehow caused. It probably is generally where this current hit resistance. Or it even went this way. It's hard to say in this region what happened. The current's a little more clear here through this spot and back through here that there was a current flowing through this, through here. This is pretty clear, especially with that. And then that it turns here is pretty distinct. It turns off of it. And this continues. And this looks like pretty distinct here. But over here, it looks like it's here, but it kind of fades into whatever's happening. Maybe even goes this way. Maybe it went out here. Oh, maybe it went this way, like here, along this path, like that. And then this one maybe came up here, went out this way, and met resistance. Because right here, we got. Let's go to this. California Mirror. Oh, this is the wrong one. It starts here, and then it goes up here. Philippines are adjacent to here. Here. Here's that. I was just showing here because I'm too busy just marveling at my awesomeness to realize that made no sense. I'm so on top of this one. Okay. So the Philippines seem to have a physical shape in them that is I believe here. I think I was drawing it here and then over this way and then up this way, over this way, up this way, I believe. Not quite. So it's not actually what I didn't actually draw it with this current. This current doesn't even follow it. That's right. That's right. This current does not follow it because it actually seems to be more involved with the shaping of nearby, like this region, not the actual underlying like current. So in essence, there was the same like general process interacting with the Philippines as was occurring in the Juan de Fuca plate in terms of the currents that were present. And so whether or not it was physically on top of it at the time, probably not, but I'm open to the possibility. But it seems like it's just like the same currents, and so they could have the same effect. I don't know. Although it really no. Like when this one, when I look at this region, it really looks like it was there. Like the nuances of it here, like it looks like it was here. This looks like it was here. Like physically in the same location to a point where maybe the shapes underneath it are like kind of what it was like underneath it. And it just broke away and like floated off as chunks were just pushed off from the general current flowing across this way, overwhelming opposing currents here. So the Philippines are forming in this region, so that's going on, and while they're forming, they're producing like these cross. I think that's like here. Oddly, it's not like visible so much here. So it looks like on the surface, though, we have a double currents here, but maybe are actually two opposing currents directionally and not like flowing together, although they seem to be coming from the same current here. Like this one current is going this way. I believe it's going in here. It generally goes in like the whole of it, but then it fills the region and kind of pushes a boundary over that then forms a boundary. So then it flows in this way, up this way. So maybe it flowed in the whole of the region, but then it like went to an end and looped back around like this way. It went down this way and this way. I don't know if that makes sense. No, and this way, maybe through here, joining back with this inlet current, but also crossing it down through here. It's possible there is some kind of double loop going on there. My thought is that this here was maybe initially wedged in here somehow. It's very odd, like exactly what happened. I don't know. In that regard, it seems like this even looks like it's from here. Like that chunk isn't just missing; it's right there, just like abutting against the chunk itself. Let's say it's not quite the right shape. It seems more like it just opened, so maybe that's not reasonable. That's what I was thinking, but maybe it did just like it didn't open and it just cut off a little like a flagpole. Let's see, let's start from the flagpole beginning. 150, 287, 341. Maybe like here. Then to here. That's about 150. Then what did I say? So I'm 257, maybe 341. That's probably not. I mean, it's not the worst. I also didn't wrap around here. Not the worst fit. And then I don't know why it would be like that though. Unless it had like its tip broke off too. Like these chunks are kind of the tip here snapped and rotated around it. As it moves around, it like breaks off a chunk that rotates. Gets caught on the Philippines from this extension. So then this current that was going through up into this region and circling, maybe it then starts to exit, goes through here, and like energetically connects with a backstop. Like it was physically moving this way with a current extending outward that's just running outward as it goes. But then the island itself is caught or holds the current enough to like provide a bond as the final result, maybe, where they become bonded. Something of that nature maybe is going on here to make them become bonded. Also, it seems like this is where this region attached, generally here. Like, it did go to here, to here. This was down here, and then the bottom top with Borneo here, down here. Like this, I just kind of cut it off, but I'm thinking it just generally extended and wrapped around it before it quite had the shape that it has. Maybe they still hold the shape to a point where it pretty much is like this neck width to here, 175 miles from like here to like here. I don't want to go too far, and it seems like here. Let's start here. Okay, this seems like a plausible outer boundary, but it is kind of substantially carved through with current, which kind of makes sense if it was the boundary here just getting carved through, separating them there. But initially just going around it. To kind of balloon this corner, I guess, because essentially the Philippines are down here. Somehow, I don't quite understand it. It seems like there's accretion going on, first of all. But still, somehow, the Philippines, which ends really at the up here, I guess. I think I put that kind of where it should be to the best of my ability. And this ends over here. Like, they don't really quite connect. There's this space here, and even if I... And this almost has to be hinged to this side, at the least. So it seems like there's some anomalies here that need explained in this line of reasoning. But I don't want to get too caught up on this right now. I think it generally does, like, that is seeming pretty reasonable sequentially. The accretion of new material up here is probably what's making it not fit quite right. Like, maybe it just wasn't, certain regions just didn't exist at all. And like it was already detached before that region even formed, maybe. So maybe there's something of that nature going on up here where this region detached quickly, but then these regions stayed more adjacent while the accretion was occurring. So current was just generally going up here and causing like a swelling here. And immediately spacing Southeast Asia, like up there. While this is all forming along the boundary line still to interact with the boundary line and be influenced by it in its shaping. Maybe something of that nature. It is a smaller globe, so it's hard to really do it without actually having the... Maybe if I took pieces like this, if I could somehow get a globe that I could just put small pieces like this on it, have them take the shape of the globe, have them all at least preset to be the appropriate relative sizes to one another, and then try to like fit it all together. That would probably help me see how they were together, but with my means that I have right now, I'm struggling to actually precisely map this region. It is so complex. Okay. I found this interesting. It also caused it to rain, this volcano. And so the ash that was on people's roofs, the ash everywhere that got wet, cemented, basically. So ash behaves as a cementing agent, or cement, when wet and dries. And it also added a lot of weight. It's almost like a powdered rock. Just add water. Oh my god. And this was also interesting. The water, it flooded, but it was flooding and bringing sedimentation that was loose from the event with it, and so it basically the the flood that was caused by this rain occurred. It flooded initially water, but then it became 80% sediment, 20% water flows of basically sediment. So like, whoa. Just like repositioning things, and it's almost like it's so energetically doing it that it like needed rain to really quickly stabilize. Like wind wasn't moving things enough. Like everything's out of sync. This sediment needs to be like more distributed after this crazy event to like an equilibrium to into the troughs, not just like everywhere piled up, and it needs to be more balanced. So it like caused the event energetically, maybe in some way. Okay, so I was initially thinking maybe there's an energy propagation going this way generally, which then when it gets to Mount Pinatubo, it runs into resistance of just like a wall that causes it to physically like hit the wall and go up basically, which then leads to like volcanoes in certain locations like that. So I was thinking that maybe there was something of that nature related to it. So maybe let's keep looking at what else is going on here. 2 weeks after the earthquake, steam, and then 8 months later, more earthquakes, northwestern side. Earthquakes of increasing intensity were felt over the next 2 weeks, and it became clear some kind of volcanic activity was likely. On April 2nd, the volcano woke up with phreatic phreatic eruptions occurring near the summit along a 1.5-kilometer long fissure. So it just opened up along a length, which, like, if there's a current that hits a wall and it goes up, like, it would kind of do it like that, like in a... So maybe long fissure also related. Over the next few weeks, small eruptions continued. Dusting the surrounding area with volcanic ash, seismographs recorded hundreds of small earthquakes every day. Scientists immediately installed monitoring equipment and analyzed the volcano for clues as to its previous eruptive history. Radiocarbon dating of charcoal found in old volcanic deposits revealed the last 3 major eruptions. Explosive eruption periods in recent millennia. 5,500, 3,500, and 500 years ago. Geological mapping showed that much of the surrounding plains were formed by lahar flood deposits from previous eruptions. Volcanic activity increased throughout May. Measurements of sulfur dioxide emissions showed a rapid increase from 500 short tons per day to 5,000 in 2 weeks. This implied that there was a rising column of fresh magma beneath the volcano. After May 28, the amount of sulfur dioxide. Oh my God. Being emitted decreased substantially, raising fears that the degassing of the magma has been blocked somehow, leading to a pressure buildup in the magma chamber and a high likelihood of violent explosive eruptions. So it starts to vent, and then the venting stops, and they're like, wait, it's blocked. It's blocked because the vents isn't like the gas was the leading current, just the wind practically sweeping from the underbelly. At the same time, seismic activity previously concentrated at a depth of a few kilometers below a point about 5 kilometers northwest of the summit shifted to shallow depths just below the summit in early June. It's a precursor of volcano-tectonic earthquakes. Given all the signs that a very large eruption was imminent, the Philippine Institute of Volcanology and Seismology, assisted by the United States Geological Survey, worked to convince local inhabitants of the high severity of the threat. A false warning might have led to cynicism about any later warnings, but delaying a warning until an eruption began might lead to thousands of deaths. So the volcanologists were under some pressure to deliver a timely and accurate assessment of the volcanic risk. 3 successive evacuation zones were defined, the innermost containing everything within 10 kilometers, the second extending to 20, third to 40 from the summit. Okay. On June 7th, the first magmatic eruptions took place with the formation of a lava dome at the summit of the volcano. The dome grew substantially over the next 5 days, reaching a maximum diameter. So it begins as a slit, but then it like comes up as a focused escalation of eruption. June 12th. Let's go back a little. Earthquake July, earthquake March. 8 months, and then another 3 months later, we have finally the eruption itself. Beginning of a new, more violent phase of the eruption. A few hours later, the same day, massive blasts lasting about half an hour generated big eruption columns, which quickly reached heights of over 19 kilometers and which generated large pyroclastic surges extending up to 4 kilometers from the summit in some river valleys. 14 hours later, a 15-minute blast hurled volcanic matter to heights of 24 kilometers. Friction in the uprushing ash column generated abundant volcanic lightning. A third large eruption began on June 13th after an intense swarm of small earthquakes over the previous 2 hours. Lasted about 5 minutes, and the eruption column once again reached 24 kilometers. After 3 hours of quiet, seismic activity began growing more and more intense for the next 24 hours until a 3-minute eruption blast generated a 21-kilometer high eruption column at 1309 on June 14th. Tephra, fragmented material produced by volcanic eruption regardless of composition, fragment size, or emplacement mechanism. Fall from these 4 large eruptions was extensive to the southwest of the volcano. To the southwest. To the southwest, which would support that there was basically a general propagation of current to generally to a wall, a boundary where instead, because the current underground would like to just go through and out this way, physically atop the surface of the ocean practically. But there's a wall in the way that's thick, and so it goes to the wall and then goes up the wall, but then its general propagation is still maintained, so it goes largely to the southwest in this direction and in this direction, it seems. Some going this way and this way, but definitely more that way. Where maybe each of these eruptions are really tied to the earthquakes in their spacing in some way, even though they're much more boom, 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 2 days. Dacite was the dominant igneous rock making up the tephra in these eruptions, and in the following climactic event. The most abundant phenocryst minerals were hornblende and plagioclase, but an unusual phenocryst, I don't know if I'm saying everything right, mineral was also present, the calcium sulfate called anhydrite. The dacite magma was more oxidized than most magmas, and the sulfur-rich nature of the eruption was probably causally related to the redox state. Final eruption began on June 15th, caused numerous major earthquakes due to the collapse of the summit and the creation of a caldera 2.5 kilometers in diameter, reducing the peak from 1,745 meters to 1,485 meters, so 260 meters in reduction. All the seismographs close to Clark Air Base had been rendered completely inoperable by 1430, mostly by supermassive pyroclastic surges. Intense atmospheric pressure variation was also recorded. Okay. On the same day, a typhoon struck the island. Interesting. I was like, maybe it was so in need of energy exchange that it made a storm. And then a typhoon struck it. Like, whoa, that's some buildup of exchange. Rapidly developed on June 11th. Just before the eruptions began. Attained its peak intensity June 14th. Strong wind shear soon impacted the typhoon and caused it to rapidly decay. The storm struck southern Luzon early on June 15th as a minimal typhoon before moving out. Although the storm itself caused significant damage, the worst effects were related to the system's heavy rains mixing with volcanic ash from Mount Pinatubo, creating massive lahars that killed 320 people. Oh my god. The eruption column in dark gray can clearly be seen from the through the storm's clouds. Crazy. Crazy. There's gotta be a tie. There's no way those are not related. It's just cooling and called a vortex to it to exchange energy. Practically. I don't know why I want to do that all the time though, to a point where we'd see it almost too much to not. Maybe it does happen more commonly than I'm aware of, but that seems like something it would be I don't know, I might not have heard about it if it was something where there's more than one instance of a volcano that's some major storm, especially out in the islands. I can see inland, United States, it's not gonna have a hurricane develop when Mount St. Helens goes off, maybe. But maybe sometimes it happens with enough explosivity. Hawaii maybe doesn't have enough explosivity, so it doesn't really draw storms like that. Essentially, explosivity would be like oomph. So current, really, the amount of current it has, flow, at least in some sense. So, like, it would kind of make sense if something's really explosive that it could drive a more energetic storm out of the currents that it induces, influences on its surroundings. Okay. That's all I got for now. I just thought I'd maybe talk on that a little bit, just because of its location relative to these kind of currents I've been looking at. Mind you, I know almost nothing in terms of like all the volcanoes in the region. Somewhere I pulled up. I don't know. Volcanoes, Philippines map, images. Because we can kind of see if they follow, like something like this maybe. So they're on the outside of these currents coming in this way and out through around here and up this way. Not sure why. More interested in this region, but it does kind of generally follow this one. And then this one bends off this way, so it fills in some of these. And then goes up this way. So a good amount of these look like they're in the proximity of these currents flowing through. I don't know if like every one of them could be explained in that way, but maybe they have different like variations of what type of volcano they are. Some are formed maybe more by like straight up eddies where the currents are not really, but like because there's a current going this way, there's a current going this way. So in this region, maybe there's a like a general current going maybe this way, and this one maybe goes more out to this boundary, around like a boundary where this just goes in like a spiral underneath it to a degree, to at least produce some volcanoes in the region that are maybe of a different variety, just like spitballing here, of course. But where they're not all necessarily like as influenced by this earthquake type things that just would cause like a current to flow into a wall and like up through a channel, pre-existing channel, and just emit through it again and repetitively. Anytime like currents splash underneath, they just flow up the channel. And then they bubble out pretty much just like bubbles. But extensive bubbles that reach 24 kilometers in the air. Uh, let's see. Volcanoes, Southeast Asia. Whew. They're really more so in these islands that had currents flowing, not so much this island that stayed largely shaped as it is. Like, it's pretty much continental shelf. It's not even really an island practically. I mean, it is, but it's like so physically conjoined to the actual mainland of a continent that it, like, even all of this, like, all of this is one unit underneath, like, unlike here, this space in that regard. And so and that's because it didn't have as much current flowing through it. yeah. Okay, so... For sure, current goes like wrapping around here. This is pretty crazy. Just the sheer quantity of volcanoes there. How crazy is that? Oh my god. Just looking. Any clues what might be going on here? I haven't, in terms of like generally there's a current going this way. And generally it's running into resistance, but where is that resistance really coming from? I do believe this region was up here though, so really that resistance maybe might have been coming across from here, like this way, and then underneath here. Which then maybe... Actually, this boundary was about here, so it's kind of like Australia dependent. I don't know what to make of that. Let's just come back to that some other time. See y'all later. Peace out.